Hello students, welcome back. So that's a question on series, an interesting question, definitely a very interesting question. So see, this question I got as a doubt just few days back. So I added it, this question in our series. Which sequence is it? So that doesn't matter though, which sequence is it, but it's a very common sequence. We should know about it. This is Fibonacci sequence, okay? Which sequence it is? So it's the Fibonacci sequence which has been defined in the question here. So what is it? So first two terms are 1, then you add them, the last two terms, you get the next term, then you add the last two terms, you get the next term, then you add 3 plus 2, you get 5, and then 8, and then 8, 5, 13, 13, 8, 21, and then 34, that continues. Okay, so that is a question based on the series related to Fibonacci sequence, but as I said, it has nothing to do with the sequence here. It has nothing to do with the sequence here. Okay, but still, it's a interesting sequence, so that's why I thought I should discuss it here. Now see, we have to evaluate it, and we are given this relation. That's how we define a Fibonacci sequence, bachcho. Okay, so now again, what the choice we have? If we have to solve this series, bachcho, what's the choice we have? Do we have any other choice than trying to break it as the difference of two terms? And if any one of you have done it, then that's really good. That means you have understood very well now as to how to approach such type of question. You don't have a choice. You don't have any result, any formula for the series related to Fibonacci sequence or anything like that. Okay, so we don't have a choice. So see how I started. I started by writing the general term here in numerator as an plus 1 minus an minus 1 upon an minus 1 into an plus 1. So now you will say, how can we write it? Of course we can't write it until I balance it, so I balanced it. And how did I balance it? I balanced it from here. I can write this one as an plus 1 is equal to an plus an minus 1. So replacing n plus 2 by n plus 1 here. So you get here an plus 1 minus an minus 1 is nothing but an. So I'll be replacing this by an. So I won't divide it by this, rather I will divide by an. Now see what happened. So now I can write this entire thing as difference of two consecutive terms, which is an minus 1 upon an plus 1 to 1 by an. And then I will say that I was really lucky enough here that we got the answer. Okay, so n goes from 2 to infinity. Now look how. See, I will bring this inside, and now this is an into an minus 1 minus an into an plus 1. Aren't they, this one and this one, aren't they the consecutive terms? Here in this one, if I replace n by n plus 1, you get this term. Okay, so now just open it. So once you open it by substituting the different values of n, starting from 2 of course, so what do we get? We get here 1 by a1 into a2 plus 1 1 by a2 a3, then plus 1 by, if I replace n by 2 here, I replace 2 in the first term, so I am replacing it by 3 here. So it will be 1 by a3 a2 minus 1 by a3 a4 and so on, and see the terms started getting cancelled. As see again, since you had difference of two consecutive terms and you are left with one term in the beginning, you will be left with one term at the last with negative sign. Okay, now a1 is nothing but 1, a2 is nothing but 1. Okay, so that's 1, and since the last term you will be left with will be having something in the denominator as n approaches infinity. It's an increasing sequence. See, that's what I wrote here. As you can see, it's an increasing sequence, so it will go to infinity and 1 by infinity will go to 0. So this is nothing but, so S is 1 here. So that should be the answer here बच्चों.